Hello to everyone who is hopping on to join our call today. We're going to give it a few minutes here, let some people join and hop onto the call, and then we'll get started. And again, thank you to everyone who's hopping on. We're going to give it a minute, allow a few more people to join, and then we will kick off our presentation. All right. Thank you everyone for joining today's webinar. This is Insights for Prefab with Steve King. As a reminder, this webinar is being recorded and we'll forward the recording to all registrants after the presentation. You can always find more Evolve webinar recordings, demos, and useful Revit tips on our YouTube channel. So make sure you're following us on YouTube at Evolve MEP. If you have any questions during the webinar, please submit them using the Q&A function in the Zoom toolbar, and we'll definitely have some time at the end to take questions. All right, and with that, I'm passing it over to Steve King to kick us off today.
Great. Thanks, Marina. Good to be here with everybody on the call today. Thanks for taking the time out to join. We appreciate that. We'll kick off just a little kind of introduction for myself. I've spent 33 years in the electrical construction industry, but about 14 years, I guess, prior to coming to Evolve, really focused on design to fabrication workflows and processes. And then in 2020, I joined Evolve to build our cloud-based product tools for the MEP trade contractor. So I've been in just about all positions that you can have inside of a trade contractor, and so I've kind of have a bunch of lived experiences that we're going to try to share some of that with you here today on the call. I kind of always kind of start with this, and it took me a while to realize it when I first started out. And I think for most of us, our fabrication journey kind of begins the same way. Just get it done in the fab shop, do whatever need to get it going and get something out to the field. But as things begin to scale, that becomes increasingly difficult to do. So after a year or so, I was pretty certain of this that the fab shop had to transform into a manufacturing facility in order to really move it forward in a way that is much different than how it is when you first start out. So just wanted to share that with you. I'm sure everybody on the call has seen this as well. For today's webinar, I really want to talk about a few things that have given me trouble in the past and things that I think about around lead times. There's a couple of different ones we'll talk about today and the importance of those, along with WIP, our work in process, what that looks like, and some pitfalls and things to avoid in terms of WIP. And I'm talking about in the shop, not on the job sites. And then I'll take a look at some look aheads inside of our tool to see what's coming in for fabrication that has not yet been submitted. So just being able to take a look ahead and see what's coming down the pipe for the fab shop. So these are kind of three of the main points we'll talk about here today. So let's dive into lead times and get started. I want to get started with a poll question first. So Marina, if you could launch that poll question to the audience, and let's see what we get for feedback here.
Okay, answers are rolling in. I'm seeing a lot of no. We are not tracking that at all. We've got a couple of people saying sometimes, somewhat. And yeah, with about Most people having answered. Here we go.
Okay, so looks like about 80% of our group is not tracking it at all. Um, okay, so that's good to know. So we'll talk a little bit about the importance of those lead times and how we can use them to become more efficient in the shop. So why is the lead time report important? Now, I won't go into all details about lead time and a whole 25, 30 slides about this, but a lot of this is available. You can research these things too, but I'm trying to summarize these points in a way that I thought of them when I was fabricating and inside the facility. So to me, lead times were always the most important for a driver schedule. And it was really kind of critical to get that right. Um, at first in fabrication, we didn't really think about lead times. We just feel people send orders in and we just get it done and get it to them as fast as we can because we want them to use prefab and we encourage that. And we want to take orders from everywhere and just simply get it done somehow to build confidence and trust in our fab organization, which is, I think, every way that everybody starts out. But it really has to be thought of in terms of how much time do we have to manufacture and how much time does it take the shop to do this in a way that makes sense where they're not just always jumping through hoops. So understanding that lead time is important and it really should be considered in the schedule for fabrication. It allows our project teams to plan accordingly. Um, for our electrical contractors on the call, I mean, you couldn't order your switchgear this way. And mechanical guys, I mean, you're not going to order your rooftop units that way. You're not going to send a date to the manufacturer and they're going to deliver it to you. They're going to tell you what the lead time date is and when you can get it based on the time of submittal approval. So it's really important in that regard to get your shop, your field teams thinking about lead time for the shop. And it really should inform the decisions we make about fabrication. So one of the things I learned painfully is that if you don't have the time to fabricate it, you really just shouldn't do it. And that's what I kind of landed on. Um, it's just a lot of bad things happen when you don't have the time. And at the end of the day, um, somebody's not going to be happy. So there's really no way to work that. It's not workable as you scale. So here is just a kind of a graphical image of the way our system thinks about the lead time. But in general, this is good for anything, right? So there's some different lead times here. We'll talk about them individually. So the ordered lead time, and that's one of the ones that are most important to me. It's the time from the time in which the fab shop receives the order for fabrication, or what I call a work request in our system, to actually delivering that order. So it's the entire life cycle of the order and its time to be delivered. Order handling lead time is a metric that is quantifies or puts a value to the time it takes a fab manager to process an order before it can be pushed out to the shop get into the manufacturing queues. So it's how much overhead time does it take for the fab manager to get that done. Manufacturing lead time, the time to complete creating a work order from production complete. So that really is the time in which the shop manager has received and processed the request. And the manufacturing lead time is from the time in which a work order was created to the time production completed. So it's that entire manufacturing process. The production lead time itself is the actual time on task. So it's when we started the first task, production began to the end of production. So you have a timeline here where there's production actively going on this particular order. And a delivery lead time, the time from production complete to delivery. So how much time does it take between production complete to delivery? So these are kind of the metrics of lead time that we're thinking about. Today, we're going to focus on order lead time, and we'll take a look in the system at manufacturing and production lead times, but we're not going to talk in detail about those here today. Order lead time is one I really want to kind of focus on. So, what is the order lead time and why is it important? Again, it's the time from the order coming in to the time our customer, which is our projects, can actually receive the fabrication and it can provide value to the project. So it's the time to value that we're measuring here. Um, the most important thing here, I think, for me was setting the field expectation. If you're not, we've got a lot of people on the call that are not um, tracking that lead time at all, which means that it's probably not being communicated to the field because we just have no idea what it is. And the field teams would see that as, well, the last time I sent an order in, it took 5 days, or it took 4 days, or it's only in some strut cuts, and I should get this tomorrow. There's no set expectation for the field to work around. So there's absolutely no consideration for planning at that point. They will just create orders, send them to the shop, and the chips will fall where they may. Um, but this is important, and this is what I think a lot of our shop managers will struggle with, is actually having the time that's required to execute. And it's really kind of, if all this, it's kind of like a storm of things that are coming in and out. Sometimes the shop is super busy, sometimes it's not. But at the end of it, without lead times and the ability to properly schedule and execute, it's just a fire inside the shop all the time. And it's really difficult long term to work in that kind of environment and be successful. So these are some of the reasons why I think this order lead time is super important here. So um, kind of some of the challenges around managing the order lead time. I guess we can start off with poor communication. That really is one of the areas in which you'll struggle is when is it needed, kind of the who, what, when, and where. Like what are we fabricating? When is it needed? When will the drawings be ready? When are the approvals going to happen? All those things that need to be communicated effectively um, to schedule the fabrication and get it done is really um, has a lot of problems and misunderstandings there. There's just in my experience, at least in where I was, it was communication was not great, and we can always make improvements around that. And there just was a lot of miscommunications and expectations sometimes that weren't met because of that. Um, then I think of the lack of visibility. So I never had any systems when I was doing this. We worked with Excel and some of those things and Smartsheet at the end, but there really wasn't enough visibility to collaborate across our teams effectively, and it was really um, data that was siloed with one or more people, sometimes on multiple spreadsheets and that type of stuff. So there's really no way to really come together to deal with something like order lead times and how long it will actually take. But really, what this resulted is, as I mentioned just a little bit earlier, was we had already climbed the hill of good fabrication buy-in, but without the lead times, what it is just the random setting of need by dates by field teams and just pushing those to the shop without any concern for whether the shop can actually execute or not. And we'll see some of that here as we look at a few examples. But it's really difficult on the shop manager to deal with that. This one, inefficient processes, to me, I mean, one of the things that I recognized after a couple of years was that we had um, kind of the processes, the production processes, the ordering processes, the planning processes that we started with when we began our fabrication journey um, hadn't been changed for a while. We just stuck with what we were doing and we weren't studying those workflows, doing time studies on them, or even considering what are we doing and why are we doing it. We just started doing all kinds of things. And so at some point, we realized that the workflows themselves had to be addressed, and we could not continue with the original processes that we had when we first started fabrication. And our objectives had changed as well. So what we expected from fabrication when we started is not what we expected from it today. And so what you'll come down to is, you've really got to look at those fabrication workflows and update them and make them more efficient. And so basically what you have here is these type of things. There's other challenges for this, lead times for sure. This is not all inclusive, but um, the result of this is longer lead times. And so all of this kind of chaos that's happening is just extending the time in which we can get fabrication to our job sites, and the field teams can gain value from that fabrication. So what we decided and what was we had to do was we had to look at all these things. We had to get better. We had to steadily improve them over time to cut down those lead times that were just too long once we got busy. So here's just a screen um, that I want to take a look at. So we have in our system a calculated lead time, and we'll see that, but it's an average order lead time that we're using here. And basically, it is the average of all the lead times for every order we processed within this facility. And so it's telling us, okay, our lead time here is 7 days. That's the average time that it should take to move an order from receipt to delivery out to our field team. And so our field teams are not respecting that, either that or they don't know that there's a lead time in the case where uh, a lot of our custom a lot of people on the call are not studying the lead time, so they don't know about it. So the orders will just come in. So the troubling part of these three orders, and I've filtered this out to take a screenshot of some orders that came in here today. And so what you see here is that there's two orders out of three that are underneath the lead time days that we have. So we have 7 day average, and this one we have 2 days and 5 days remaining to execute these requests from the field. And so over here, what this results in is these are actual calendar days, and that there's only one business day to execute uh, this first order, and 3 business days because of the weekend to execute this one. So there's not a lot of time to execute this at all. Um, and so the issues here are the two orders that don't have the proper lead times. So let's assume the workloads are normal in the shop. We're not at 100% capacity, but the shop is busy and things are moving around as they normally should. Uh, so this is not a big deal, right? There's only a couple of orders. Um, a lot of fab managers say, okay, we just have to get this done. We have to do it, and that's the case. So it shouldn't be a big deal. But let's take a look at this and try to evaluate: is it a big deal or is it not? So here, if we consider what the fab manager needs to do to get this done, he needs to immediately stop whatever he's doing and process these orders. He's going to have to procure materials, receive, and stage this material. Now, procuring materials, maybe these things are in stock in the shop, maybe they're not. Let's just say he has to order something here. The time in which he's giving your purchasing department to get this material here is 1 day. They've got to cut a PO right now to some vendor to get this in. Maybe you have a vendor managed inventory in your shop and it's not a big deal, but it has to be done now. It has to be done right now in order to get this done. So it's not only in the operations of the fab shop that are being impacted, it's also impacting the purchasing teams and your suppliers. We definitely are going to have to shift priorities here. This is not the only three orders we have in the facility. The facility is under normal workload. And so no matter what we do, We're going to have to stop something, start something else, shift priorities, reshift priorities once we finish them. And that becomes part of the main issue with this type of thing. Hurry up and get the orders completed. That's what you're going to have to do. And then figure out how to get it delivered. So if these have to be delivered out to the job site, or your field foreman is going to take a ride to the shop and pick them up because he needs them right away. The interesting thing here, though, is if you look at this order type for this project, it's for foundation wall sleeves. So I would beg to ask the question, how long do you think that the foundation framing has been up and the rebar has been out there, and we need these sleeves in 2 days? What that really is just a lack of planning overall, that's causing this turbulence in the shop. And it's from outside forces. It's not the fab manager's issue here, to jump through hoops and go crazy to meet the demands of the field teams, in which proper planning was just not used here or considered. And I know things come up, and it always does. Construction is difficult, and things happen, and we do have to do um, certain things to get things done. But if this is the way the shop operates all the time, that's a big problem. And you'll never scale that. And even if you do, it's going to be wildly inefficient out on that shop floor. So this is kind of the root cause of not tracking order lead times and communicating those times to the field. And if you are, and the field is not respecting them, that's another issue altogether. That has to be addressed, because in order to provide proper scheduling time in the shop, you're going to have some standards of lead times here. All right, so some key takeaways on this really, and this comes from my personal experience, and I'm just trying to share that with you here today. Some of these may apply and may not apply to each one of you guys, but to me, the lead times were important. We always use them with our field teams to properly plan, and so we had protocols to handle things that were in less lead time than was required, but we didn't always approve them, and sometimes we rejected them when we simply did not fabricate it because we just couldn't. We would change things around in the fab shop to satisfy one foreman that we really like, and somebody else suffered and their order was late because of it. So we got to a point where we just weren't going to do it at all. For the most case, it had to be a reason for the exception. This one, if you don't have the time to fabricate, you just shouldn't do it, and that's just my own thought about it. A lot of times I wanted to do it, and I said I would do it, and then after I was done doing it, I kicked myself for putting myself through the aggravation of trying to do that. But I think OLT, which is overhead lead time, I think is critical for your field to understand and respect when planning for fabrication. And I think if you're not calculating those things today, or really take a look back at the historical information that you may have to try to determine what that is. And if you can't, then just study it going forward and try to work with it. And I think you'll find that it can help you out if it's being done correctly. So kind of to wrap that up, I want to jump into WIP, so work in process. I'm sure everybody on the call knows what that is. For the purpose of this webinar, we're talking about the work in progress within the shop itself. So the question I have is can WIP sync your productivity in the shop? And so before we started a task, and tasks are kind of children of the work request, or the items within our work request. There's tasks that need to be executed, but we ask the question first, do we have the information, materials, approvals, decisions that are needed before we can begin? And if we didn't, we had to determine what was going to be the outcome of that. Maybe it was a large order. Maybe we're making 1,000 widgets or whatever it is, and we can get started and start making, just get started and start making them, and then the material come in. Um, and some organizations I see that just simply won't start any fabrication without the materials, and sometimes you'll start it with or without. But that's up to you how you guys do that, I guess, based on whatever the conditions are. Um, but if you don't have what you need, at some point, you'll ultimately be creating more WIP in the shop than that system can handle. So there is a finite amount of work in progress that our projects can handle at any given time. The shop, the office, it doesn't matter. It's human beings doing this work, and there's only so much work the system can take before it kind of eats itself. And so that's what I want to really talk about here, work in progress. And so um, some things to think about here, and I certainly noticed it in the early days of fabrication, is that um, the more tasks that we started, the less we actually got done. And I think about it even in my home life. I'm working on my house, and I seem to not finish things like I should. And you get tired of it, and you start something else or whatever, and you got five things that you should be doing, five things at home that are started, and nothing's done, and sometimes they never get done. Um, but anytime you start a task, so the thing to think about here is, I'm not sure if you all are tracking tasks on the shop floor. But anytime you start something, you're basically creating WIP, right? That's how it is. As soon as you start it, it becomes WIP. And so here is an important takeaway, I think, and this is the way I think about the goal. The goal is not to start stuff, and it's just human nature. If we don't have anything to do, we're going to start something else because we need something to do. It makes us feel good, and we feel like we're working hard, and we're starting all kinds of things. But the goal is not to start tests. The goal is to increase throughput on the shop floor. We have to get work in and work out. And if it's work in progress that's stuck in the facility, it does absolutely nothing and it provides no value to the project or the company. It's just work in progress that is stuck and can't get out the door. So, really, when we think about the shop, we're talking about increasing throughput, which is what we need to do to get work in and work out of the facility. So, too much WIP, some things here, too many tasks in motion, right? There's too much going on in the shop floor, inside the work cells. People are waiting for things. There's bottlenecks, um, unforced shift priority changing, starting, stopping really is what is problematic. You pick something up, you start it today, you work on it a few days, and then you don't pick it up for another week. You got to go back, you got to relearn, you got to look at where you left off, you got to, all that stuff has to happen and when you have too much work in process. And so at the end of all that, what really happens is it just has a negative impact on throughput. And um, there's a comfort level with how much we can have, and there's always going to be some problems. But when you have too much, you have all these types of things. So some of this probably is familiar for you guys um, in your shops today. Everybody has it. We're not exempt from it, but to what extent we have problems is what we're trying to solve. We're trying to make incremental process improvements, not change the entire system overnight. That's not possible. So we want to make improvements here. So we're talking about what we can do to lessen the work in progress and get things done in a logical way on the shop floor. So what is there's a comfort level, and it's kind of a pendulum, and you don't know what your sweet spot kind of is. You can feel it. You can feel it in fabrication. You can see it if you walk on the floor. You can see when it's all hell's breaking loose out there, and you can see when things look pretty smooth and continuous. That's just an indication of how the shop is running at the time. But there is a place where the shop is comfortable with the number of people you have out there on the floor and how much work we have in progress within those work cells. So we'll talk about how we can actually see that. Um, But the point of this slide is, I think that you'll at some point your effectiveness is actually going to drop off. So as you approach this place where you've got too much whip, you're going to find out that you're late on everything. Things aren't getting out the door. Shop managers shipping material, moving stuff, shifting priorities, starting to stop and everything. Just really jumping through all kinds of hoops to get it done, which is not normal. Like we don't want that condition on the shop floor. Um, so here's a good thing. It's like it's our nature to start things, keep starting things, but at the end of the day, you're going to be keeping busy. You're not going to be getting work done, and so that's the difference on this one. So finding the sweet spot is what we're going to try to find. Um, so think of WIP as this funnel that we're that our design teams, our field teams are pushing work into the funnel, right? We're moving work, we're sending work to the fab shop, and the work is steadily being released into the funnel. We have the information, we have the materials we need, we're executing the tasks. There's a smooth pace on the shop floor. You can see it, you can feel it if you're in that environment. The shop manager is probably smiling once in a while instead of, you know, being pissed off or whatever the case may be, trying to solve all these problems for all these projects every day of his life. And, I always kind of joke around thinking that saying that, fab shop managers really just put on their Superman cape every day and come to work. And if they don't come to work, there's a big problem. And that's because of process. And so those guys really, without good process, they kind of get punished every day, have to work like this. So we think of it as a funnel. We're pushing work into it. Work should come into the funnel, should go out to the funnel very smoothly without too much turmoil. Um, but you can only go so fast, and there is a limit at the bottom of this funnel. So you might say, well, let's just get a bigger funnel and pour more crap into it. You can do that. You can hire more people. You can get a bigger fab shop. Um, you can buy more machines and tools and stuff. At the end of the day, you're just going to be jamming more stuff into that funnel. And no matter how big that funnel is, there's still going to be a bottom. So that's not really the answer. The answer is our process good? Do we have good process? Are we efficient, effective on that shop floor? And some people will skip by that and say, well, we just need a bigger facility. Well, you just get a bigger headache. That may not be the answer in some ways. So if I would certainly rather have 20 people on the shop floor working 85 to 90% efficient every day than 35 people on the shop floor working 65% efficient, because 65% efficient is just a few clicks better than what you're going to get on the job site. So the fab shops have to be much more efficient than a job site. But so here's just an example up here in this image. You're going to start seeing that the push into the funnel, things are starting to happen here. There's bottlenecks beginning to form. These are start and stops of the work orders on the floor. It's WIP, work in progress that can't get through the funnel, starting to build up. And then obviously this is just not a good situation where you have nothing getting completed, everything started. Nobody's happy in this situation. So what we have to do is really think about, we need to learn to stop filling up the funnel to outside forces. And the outside force in the last couple slides I showed about the work orders being submitted that were not within the lead times of the shop, that's an outside force. That is not a problem for the shop manager. It is a planning problem that is an outside force that's disrupting the flow of the shop on the floor. And so it's an outside force that's affecting us in the shop. And so we really have to look at the entire operational workflow when we allow that stuff to happen. We know that this is going to happen here. It's going to happen. So you have to learn how to deal with sometimes saying no. So let's stop here. It's a good stopping point. I think we're doing pretty good here on time. So let's hit out that second poll question. about WIP, and let's see if we get some tracking of tasks on the shop floors.
Great. That poll is launched. The question says, are you currently tracking tasks on the shop floor? All right, we're seeing a few answers come in, and I'm seeing a lot of yes, but we wish we had a better way to track. That seems to be the primary answer that we are receiving.
Yeah, that's interesting. We have no, not at alls. So it is predominantly you're doing it, but we need some improvements to that. So that's good. Glad to see that tracking is down at the shop floor, at least at task level. That's a good thing. All right, so let's continue on here. So one of the ways, so how do we determine optimal WIP in the shop? So for me, and our system, what we have in our system provides visual management of that. And the visual manage of that really puts all the information that we need at the point of use, the shop manager, anybody that has a need for this information can see it. And all of that information is not in somebody's head. It's not in the foreman. Some shops you'll see a foreman that just he knows everything. There's no system. There's no real anything. He just knows everything and he writes it down and he's going to get it done. And God forbid he goes on vacation. All hell hits the shop at that point. But so this is the way that I think that it was easiest to kind of deal with WIP, seeing it first. So uh, what we're calling here the WIP board in our system, it's a work cell Kanban board, but it is in essence a WIP board. It's what work is in progress at any given time. And so it's really three things here. There's a queue, there's what is in the queue that has not been started, there's work in progress, and then there's work complete. So we're moving through this funnel of tasks that we need to do, tasks that we're starting on, and then obviously the final completion of that work order, moving it through seamlessly through a logical workflow on the shop. So we're monitoring all these tasks in one place. Everybody can see it, and we're moving it through three phases of of its production life cycle: queue, progress, and completed. So this is kind of a proven system. It's used a lot of ways. A lot of systems use it, and I think it's just a good way of visualizing the work that we have in progress in that facility at any given time. Actually, let me go back here. Um, here on this website here, there's some good information about this, and I've taken some excerpts from this article, "Whip Out the Whip Board." As I was researching and reading it and getting set to put this presentation together, uh, it was ironically very close to the way that our system actually fundamentally works. So just pointing this out for there's a lot of information out there that you can get, but this is kind of some excerpts and some images from this particular work from Lean BP. So here is our funnel. Things are going through it normally. The shop is in a normal condition, and you're looking at this whip board here, and you can see that everything is really just in progress in the work cells. It seems logical. Everything here, we have a balanced workflow. We are also working from the top down, in which our need by dates are in order, and we're actually executing in the order in which they need to be done. We're not working out of sequence here. And this is kind of an ideal situation. You don't have many tasks in any given work cell that are in progress. In this particular case, this is probably a perfect case, and it won't always be this way. But for example, here, I would feel good about this condition as a shop manager, looking at this whip board and saying, okay, I see tasks going on in every one of my work cells. Work is being done in order by its need by date, and I'm feeling pretty good that we're going to be able to pull this through the shop at the end of the week, whenever it's due. So this is a condition that you would see on the whipboard that is troubling in a way and would call for the shop manager to take a look at what's actually going on here and what is the impact of what's happening here. So the funnel is starting to clog up. And the reason it's clogging up is because we've got multiple tasks going on in this cutting work cell, and it is also working out of sequence. So um, here you can see there's some work going on that's due on 11/6, and then we're jumping to something that's due on 11/19, 11/29. And way down here, we got something on 11/13 that is not started yet. And the downstream effect of that is going to affect the work that's going to need to be done in work cell number 5, which is where we assemble our trapezes, which is a predecessor to cutting this steel, right? We can't assemble a trapeze until we cut the steel and we cut the rod. But we have not done that yet. So as a shop manager, I'm looking at this and I'm saying, well, there's something wrong here. Why are we doing this? Are we waiting for information? Nope, we got that. Well, what is it? Okay, we don't have the materials. We ran out of materials, or we built it and we messed up 50% of them and we got scrap and we've got problems. This is just so visually here, without walking to the shop floor, I would ask myself, what the heck is going on in the cutting work? So I'd go down there, I'd get with my lead guy, and I'd find out what is going on. How do I unblock this as a fab manager to ensure that that funnel doesn't get clogged and that we can get this stuff out? So this is just a way, if you don't have a whipboard or some way to see this, it's very hard to recognize that. Just walking the floor, you might not even see that this is a condition because there's just work in progress. It's on the floor, it's on a pallet, it's on a skid. Looks like they're busy. We must be doing good. But busy is not always good. So this is a way that I would be able to see potential problems coming down the road. And there you have it there. So those are the really the problem tasks that need to be looked at, see what's going on. So I'm going to take a jump into the system right now. Let me bring that over and just take a look at some of the ways that we see that in our system. And there's um, obviously other ways to do this. I'm just going to show you some information we have in our from our insights. So here we can see our system, and we're talking about work requests here in our insights module. And so we're looking at the average order lead time days that are being calculated here for us automatically. And that again is the time the work request is submitted to delivery. And so our facility, we can look at one or more facilities. In this case, you can toggle between your facilities. Maybe we've got mechanical contractors that have a duct shop and a pipe shop. And so there would be a difference between those order lead times for those different facilities, but you could see that it would calculate based on the facility. So here we're looking at one facility and we're looking at this year. We can also take a look at lead time in terms of, how this has changed. So we could take a look at date ranges, and maybe we want to look at, maybe July Q3 or something. Maybe we want to look at Q3 and see what our lead time was for Q3. And so we could just pull that and look at that data. Well, in this case, it's showing that our lead time in Q3 was 6 days. Now there's a lot of reasons for that. It could be the shop wasn't very busy, and so work could get out faster. But it could also be indicative of that now today we've got some issues that we need to deal with because our lead time creeped up to 9 days from 6. And so the lead times will fluctuate with people and processes. And so we're able to kind of queue up that data and see what's happening with that lead time. But this is the date that our field teams would understand. They can see this in real time themselves. We don't need to tell them when they order it. They can see that our lead times are currently at 9 days, which is nice because some of us get very busy sometimes. Sometimes our shops slow down. Well, 3 months ago, you could get something in 6 days, but now we're super busy and it's going to take 9 days to get it to you. It's just a fluctuation based on workload in our facility. Um, so that's one of the lead times there around orders for fabrication. Um, we'll take a quick look at here. I didn't have slides to talk about this manufacturing lead time, but here we're looking at all of our facilities. So we could average out across all of our facilities and get this. But again, if you have multiple facilities or multiple locations, you could look at this by location. And so here for this facility, our average manufacturing lead time is running 12 days, which is the time from the foreman in the shop receiving and processing and creating the work order to the time it's actually completed. Now, there's a difference here in the production lead time because the production time is actual when a task is started and production is complete. So here there's a 3 day difference. The difference is the processing of the shop, order materials, waiting for materials, wait times in the work cells. Maybe you're waiting, whatever that is, that's the difference in those 3 days. So really, our production time for anything is averaging 9 days, and we have a 3 day wait for some reason, whether it's material, information, tools, equipment, whatever. That's the reason why these two are different. So when we think about manufacturing lead times, we're saying, okay, and by the way, you might ask why my overall lead time, my OLT is lower than this. It's because I've got bad data in my demo system. And so that would, you should never see this reversed like it is in my system here. But it's demo data, so it's got some not so great data behind the scenes. Um, so those are how our system takes a look at this. All of this is available out in detail too. So if I want to look at the detail of this, we can get all this data out of the chart and look at it in a grid detail, where we can look at project specific times. We can also take a look at a particular project and look at that project's lead times. And so we can filter this. We can capture the time it takes for every order to be manufactured and calculate and then average out. So we're collecting all the data and starting to push it out to the shop teams and management teams to be able to look at this and actually make decisions from it. The WIP in the shop is really easy to look at too in this grid detail. So if I want to look at the work orders here, I can simply say, okay, show me everything that's in progress right now, and I can get a WIP report from my shop right here. This is simply all the orders that we have in fabrication today, when they are needed on the site, when we approved it, when it went into progress, and as it's moving through, we're capturing all the production data associated with it. So this is just how our tool works. There's a lot of ways to do this, but this is just an example of how we do it. So kind of to wrap up here, we're getting close. I want to take a look at, and I didn't put any slides together for look aheads, but I did mention it. So I want to kind of show one of the things that I like about look aheads is in our system, we can use fabrication and we can plan for fabrication. And so if we're planning ahead for fabrication, we can take a project and simply plan its fabrication out. So we know, sorry, let me get to a project that has some of that. So here we have a project plan where we know what we're going to fabricate on this particular project. We just don't know when. We don't have dates when it's needed on the job site, but our VDC teams are working on these. Design is in progress. And then eventually the field teams will bring scheduled dates to these items as they work that through out in the field. So now we know we've got some things that are coming in November. And so the fab manager just simply wants to take a look at that. And so we can do look aheads here and just simply come into our system and say, okay, show me what's needed, what's coming down the pipe. So give the fab manager some idea of what's coming in November. And so we can just take a look at that here. And we would want that to be draft status. So everything that's out on the projects that have not been sent to fabrication. And so these are actually planned fabrication that is going to happen. They have not been submitted yet to the shop, but we can see a picture of this, what's coming up in November, and we can see that our days remaining here are 14 days. And so if you look at your lead time and your lead time's 10 days, you would be expecting this order within the next 4 days. Um, so this is just a way to do fabrication look aheads from project planning that's been done at the project level that has not been submitted. Um, so with that, I think I will open it up to Q&A, Marina, if we can. Any questions from anybody?
Yeah, absolutely. Here's a good one, Steve. In your experience when you're doing prefab consulting, what are the KPIs that you're using to measure efficiency?
Yeah, it's gonna have to be the pull through um, of what we can get through the shop and how long it takes. It's actually um, it's somewhat difficult to do it. At the time I was doing it, I never had the tools to do it effectively. Um, but I would think of it as we've got to measure pull through, and we were looking at prefab utilization was one of the metrics that we had um, before I left, and that was essentially a block of hours from the project and that were moved to fabrication and um, had a block of hours and how were we tracking against those hours for the projects in the fab shop. So we were looking to see how active the projects were with our fabrication process. But that's a work in progress here. We need to address that here as well and get that into our systems to improve that. But I find a lot of companies, especially on the electrical side, now I'm not a mechanical guy, so I wouldn't know. A lot of times I think they're measuring pounds of ductwork or inches of weld on certain things. And so we need to do some work around that so we can give that data to you guys.
That's great. Are there any opportunities with the Evolve Shop system to integrate BIM data and really align your design and manufacturing teams?
Yeah, that's interesting. Currently, there isn't, um, but we are really actively talking about right now about work packaging, and work packaging in our Revit tools is there today. We can package work, and what we're discussing internally is tracking the VDC time and effort of the VDC detailers against that work package. And then that work package heads on into the fab shop and it can have one or more work requests as a work package. But then being able to look at the overall effort against a work package expended by our VDC and shop teams to actually deliver that to the shop. So partly that would include a VDC tracker that is tracking tasks for the work package, and those tasks are being tracked and monitored so that we can move that deliverable onto the fab shop in the package or grouping, if you want to call it, of a work package. So it's a great question, something that we're actively talking about right now, and how to actually address that.
That's great. Thanks, Steve. All right. And those are all the questions that we've got today. I want to thank everyone for attending our webinar. And of course, a huge thank you to Steve for sharing your valuable experience. As a reminder, this webinar has been recorded and we'll send out the recording in an email to all registrants. Please make sure to follow Evolve on social media to keep up with all things MEP and prefab. You can always find more demos and past webinars on the Evolve YouTube channel. Thank you again, and everyone have a great day.
Thank you, guys.